So we've had a look at the domain and range of the inverse sine function and how to define it. Now let's differentiate it. So if we say y is equal to inverse sine of x, sometimes called arc sine of x, what is dy dx? So the first thing we do, if y is equal to inverse sine of x, that means that sine of y is equal to x. So sine y equals x is the same as saying that y is equal to inverse sine of x. So now we can differentiate this implicitly on both sides with respect to x. So the derivative of sine of y with respect to x is equal to the derivative of x with respect to x. So that implies the derivative of sine of y with respect to x, where y is implicitly a function of x. Well, the derivative of sine is cosine, so that's cosine y times the derivative of what's in the brackets, which is just dy dx. Derivative of x with respect to x is 1. So dy dx is equal to 1 over cosine of y. Now I don't want my answer in terms of y, I want it in terms of x. So I need to express cosine of y in terms of x. Well, I already know that sine of y is equal to x. So if sine of y equals x, what is cosine of y in terms of x? To do that, there is a formula in your logbook which says that the sine squared of theta plus cosine squared of theta is equal to 1. And that's true for any angle. If you're not convinced, take a look at the unit circle. If I have some angle theta in here, that side is going to be sine theta, that side is going to be cosine theta. This is a unit circle, by the way. That's 1, minus 1, minus 1, 1, a circle of radius 1. That blue side is 1. Then the theorem of Pythagoras gives us that formula above. The sum of the squares of the two sides is equal to the square of the hypotenuse. 1 squared is 1. So sine squared plus cosine squared is 1 for any angle. So let's apply that specifically for cosine of y. Sine squared of y plus cosine squared of y is equal to 1. So that implies that cosine squared of y is equal to 1 minus sine squared of y. Therefore, cosine of y is equal to the square root of 1 minus sine squared of y. And above we had that the sine of y is equal to x. So that is just equal to the square root of 1 minus x squared. Bear in mind that sine squared y means sine of y and then squared. So that's 1 minus x squared. Finally, we go back to our formula for dy dx. dy dx is equal to 1 over the cosine of y. And we sub that in. And we say it's equal to 1 divided by the square root of 1 minus x squared. And there we have dy dx as a function of x. So the derivative of inverse sine function of x is 1 over the square root of 1 minus x squared. So what is the derivative of the inverse cosine function? Well, we follow a very similar approach. We say that the cosine of y must be equal to x if y is equal to the inverse cosine of x. Now differentiate both sides of that equation with respect to x to get minus sine of y, which is the derivative of cosine, times dy dx is equal to 1. Or dy dx is equal to minus 1 over the sine of y. So let's go back again to our old formula. Sine squared of y plus cosine squared of y is equal to 1. We can rearrange that to get sine of y is equal to 1 over the square root of 1 minus cosine squared of y. And remember that this time the cosine of y is equal to x, so that's equal to 1 over the square root of 1 minus x squared. So let's sub that back in to our dy dx is equal to minus 1 divided by the square root of 1 minus x squared. So the derivative of the inverse cosine function of x, y equals cos minus 1 of x, is dy dx is equal to 1 over the square root of 1 minus x squared.